Hey, Julie.
Yeah, looks like we're
I'm good. How are
already live.
you?
Yeah, good. Um, yep, it looks like we are already live, so I will kick you all off. Or not, yeah, we'll start you off. So, hi everybody, welcome to the Technically Developers Conference. I'm Technically Managing Editor Julie Zeglin, and this is Reinventing Retirement Income Using Machine Learning. So I'll give you all a chance to introduce yourself, but I'll read the quick description of the session so that everyone who's attending knows what they're in for. So you're about to meet TORI, which is the tax-optimized retirement income, which is Vanguard's machine learning engine that supports financial advisors in identifying optimal retirement planning strategies that improve investor outcomes. Learn how this approach can provide more investors with better, more sophisticated financial advice and uncover new strategies not defined today. Would you all like to introduce yourselves? And I'll hide for the rest of the session.
Sure. My name is Christine Meehan, and I'm the Chief Engineer of the Financial Planning product line, supporting Vanguard's enterprise advice agenda.
I'm Lindsey. I'm the Product Manager for Retirement Income.
I'm Samy Movassaghi. I lead the AI/ML team for TORI.
Great. So I'm sure when most of you hear the name Vanguard, you think of the financial institution, and you would be correct. We are an investment management company with over 30 million investors, and we have $7.5 trillion in assets under management. We're the #1 mutual fund company in the world, and we're the second largest investment firm behind BlackRock. But we're also a technology company. In fact, internally, we have philosophical discussions frequently, some may call them debates, whether or not we're a financial company or a tech company. And that's because of our 17,000 crew members, more than 50% of them are supporting software development across 8 technology subdivisions. Our annual IT investment is roughly $1.5 billion. That's a significant investment, and it speaks to our commitment to drive innovation across our business in order to better serve our clients. Technology is critical to helping our clients reach their ambitious investment goals, and that is why a little more than 7 years ago, we partnered with AWS to help modernize our traditional heavy virtualized tech stack, our big data platforms, and our monolithic applications. Some are running as many as 50 million lines of code. We've either moved or are in the process of moving most of our business critical apps to the cloud, and we're using AWS to handle all new development work, specifically in the space of AI and machine learning. This strategic partnership helped us to accelerate innovation, and it transformed IT at Vanguard. I'm going to turn this over to Lindsey, who is a product manager in our financial planning product line as well, who will tell you how Vanguard is using machine learning to better position our clients during retirement planning.
Yeah, so Christine touched on some about Vanguard's technology, and one of our core areas of investment in Vanguard's technology is in building out financial advice tools. Now, we have several different financial advice offerings at Vanguard, but the one we'll focus in on today is our hybrid advice offering, where we have a financial advisor that uses technology to help make the advice that they're able to provide more affordable, accessible, and to help improve investor outcomes. We knew that we wanted to build a tool that would help people in retirement, but we really wanted to talk to advisors and investors to better understand the current needs and the current points of pain in the retirement planning process. And what we learned from interviewing advisors and investors is that the tax optimization space is a big point of pain. Because it's very complicated, there are so many moving pieces, and tax laws are constantly changing. So due to this complexity, advisors are often implementing rule of thumb recommendations, or only those who pay for very high touch advice are able to receive sophisticated recommendations, and we set out to change that. We know that today retirees are faced with many different types of decisions as they're switching from accumulating assets and focused on savings to changing their mindset, where now they have to think about spending down from what they've worked so hard to save over the course of their life. And they often want to know answers to questions like, do they have enough savings to successfully retire given their spending needs, or when they should claim Social Security, among many others. Now, most tools in the industry will think of each of these decisions separately as standalone decisions, but we had a hypothesis that by focusing on each of these decisions in an interrelated fashion, we could further drive outcomes for investors. And in fact, our research indicates that while investors will receive a range of outcomes based off of their different personal situations, we can see an average of about 50 basis points of annual benefit amount for investors taking a more interrelated approach. So we were excited about this potential and wanted to develop a tool that could help us to solve for this interrelated decision making. So we're introducing TORI, our tax-optimized retirement income product, which aims to replace those rules of thumb to provide investors with more personalized, holistic recommendations that help to maximize their after-tax wealth and spending in retirement. For our initial scope, we focused on providing investors with one optimal recommendation that included 3 different components and helped answer 3 questions. When they should claim Social Security, what accounts they should withdraw, in what order they should withdraw from their portfolio, and then whether or not they should do a Roth conversion, and if so, how much. It might sound simple, but it's actually very complicated. If you look toward this visual on the right, you can see that in order to identify which of these strategies is optimal, we have to balance many different complex tax considerations, like an investor's marginal tax rates or their balances by different account types, and consider variations in things like their life expectancies. And each of these factors is highly dynamic, so it stays pretty complex over time. And when we looked at the Social Security claiming strategies, withdrawal order strategies, and Roth conversion strategies that we wanted to optimize for, we ended up with 972 different options. And we also know that markets change over time and market outcomes change over time. So we needed to look at all 972 of these strategies across 10,000 different capital markets projections to really identify what we define as the optimal strategy for an investor. Our original product that we built, we took a brute force approach where we tried to run all of these strategies and rank them, but we were finding that it took several hours to produce a recommendation, which wasn't going to adequately meet the needs of the advisor and the investor, especially given this dynamic environment and knowing that things change and investors have different preferences. So we sought out to leverage machine learning, where we could look at all of these different factors and match an investor with their strategy without having to go through all of these different permutations and run all of these different strategies across those capital markets projections. And as a result, we've been able to significantly reduce the time that it takes to provide investors with recommendations and adequately support those conversations that advisors are having with their clients in the meeting. And we've been able to reinvent retirement planning for advisors, ensuring that all investors can now receive optimal personalized recommendations. And we even hypothesize that over time, by leveraging tools like reinforcement learning, which we'll talk more about in the future slides, we might be able to identify some strategies that we haven't even previously thought of. And that will further improve investor outcomes. Our advisors can now serve more investors and spend more time focusing on having conversations with those investors rather than spending a lot of time in the meeting modeling different strategies and trying to arrive at what that optimal recommendation might be. And the benefits of these solutions are quantifiable. So we can tell each investor as they're making their decisions how much more benefit they can gain from using TORI versus those conventional wisdom and rule of thumb strategies. So now we'll ask you, which tool would you prefer that a financial advisor use during your annual planning meeting? TORI, a model that's trained on a full landscape of personalized scenarios and recommends an optimal strategy, or an industry standard scenario modeler tool that can run through a few different strategies and arrive at the closest fit. And now I'll pass to Samy and she'll talk through more details of our machine learning approach.
Thank you, Lindsey. So the current machine learning AI model that we have and deployed in production is a classification model. To give you a little bit of context on what a classification model is, it lies in the category of supervised learning, which means that, so we're on the next slide, which means that we're using a sorry, Lindsey, we're going to the next slide. Yeah. So the current recommender that we have deployed in production is a classification model. So to give you a little bit of context of what a classification model is, it lies in the category of supervised learning, which means it requires a label data set. So the model learns to map input features to target labels, and the model can only get as good as the data that is provided. So you see on the right here, which a human tries to teach a robot about how a dinosaur should look like, and then the human steps away, and so the robot is able to identify the robot after being trained or supervised by the human in terms of being able to identify the dinosaur. So we are using Amazon SageMaker, which enables us to create, train, and deploy machine learning models throughout the process for the current recommender that we have in place. So on the next slide, it will show a high-level illustration of the machine learning architecture of the model that's deployed in production. So the model uses a variety of different features to consider to come up with the best recommendations in terms of financial strategies to recommend to the client. It uses decision trees at its backbone for coming up with a strategy, specifically XGBoost, which uses a unique ensemble method to identify the shortcomings of the weak models and incrementally or sequentially build on top of those for building a stronger model. And essentially, the architecture that we're using uses hierarchical machine learning, which is known as the best practice to come up to reduce the number of strategy recommendations for the classification models to come up with better and more accurate predictions. So in the next slide, we're going over the concept of the wisdom of the crowd, which essentially means that when we're dealing with just one model, there'll be some variance. But if the predictions of a group of predictors are aggregated, the predictions will be much better than with the best individual predictor. So a group of predictors is called an ensemble, and the technique here is an ensemble, is called an ensemble, and in layman terms, it means using recommendations based on wisdom obtained from a crowd. This helps with reducing the variance in model predictions and also improves with the overall predictions. Now, in order to tackle issues regarding class imbalance, we've been using generative adversarial networks, which are essentially used for generating new synthetic data that can be passed for real data. So their promise is to generate realistic examples, and we are using them in this context for generating targeted labels or classes for the underrepresented strategies that we need more samples of. So essentially, the architecture behind generative adversarial network consists of two submodels: the generator model that we train to generate new examples, and the discriminator model that tries to classify examples as either real or generated. Now, you might ask why we need to care so much to use a classification model, and the answer is the classification model can be integrated in the other models that are being developed for TORI to enhance their performance, and this is actually where we are headed next. So we consider to use reinforcement learning for the future state of TORI, which is essentially to train machine learning to make a sequence of decisions by interacting with an environment. So here you can see a couple of success stories of the use of the applications of reinforcement learning. On the left here, you see Breakout, where you control the bat and ball to break through a rainbow colored wall. And essentially, the RL agent is trained on coming up with a configuration that is able to break through the wall. And it comes up with understanding that it can go behind the rainbow colored wall. And this way, it's able to break this wall even faster compared to what was tried out by humans. In the middle, you can see an example of reinforcement learning being used in self-driving, which is essentially helps out with making identifying the best path to choose, and also which is critical for people's safety as well. On the right, you can see AlphaGo, which is something developed by DeepMind, which is essentially a reinforcement learning algorithm, which was able to win the Go game over the best Go player over the past decade. So these are some of the most important applications of reinforcement learning that are highlighted in this slide. So in the next slide, we'll just go over just the future state of TORI, which is essentially reinforcement learning, which we are training an agent that considers a set of states, in which are the persona features, and the actions that it needs to take are the financial strategies that are recommended. And we're essentially training an agent to take actions in an environment to maximize their long-term cumulative reward. So as the agent takes an action with it, the environment provides feedback in the form of updated information in terms of states and rewards to further optimize the strategies that are recommended to the client. With that, I'll hand it over to Christine to walk us through the integration architecture.
Great, thanks, Samy. I'll just take a few minutes and we'll walk through the architecture from left to right. But TORI is built on a modern architecture. We're leveraging AWS's cloud native platform, and we're using it for all the same reasons that everybody else is, for high performance, scalability, reliability, and agility. So starting on the left-hand side, our end client can access our responsive website, either from their desktop or a mobile app. Our web apps are built on the latest Angular Node.js, and we're running in AWS ECS, their Elastic Container Service. Our microservices are deployed on AWS ECS Fargate, and we have Java and Python-based web services. CloudFormation is also used to automate the infrastructure setup and continuous delivery and multi-region deployment. Our data layer, we're leveraging DynamoDB. As you can imagine, a company like Vanguard is subjected to a lot of compliance and regulatory oversight. So we need to store all of our data for 7 years, and that data needs to be immutable. So we're leveraging DynamoDB streams to capture those changes. We're also using the Kinesis data streams to stream data to S3. The AI and ML integration, I know Samy had mentioned SageMaker. That is a machine learning platform for data scientists and developers. And then we're also using SQS to decouple the microservices and the AI and ML models in order to scale our request. For analytics, we're leveraging Glue. We're also using an AI-driven business intelligence tool called ThoughtSpot. And then we have the data lake. The data lake is a strategic data store for Vanguard. It's a shared capability across multiple teams. So it allows us to have a single place for our data to be stored and to be accessed for analytics or even other use cases here at Vanguard. We're using Secrets Manager for security. And then when we think about logging and monitoring, we're leveraging a lot of out-of-the-box tools such as CloudWatch, CloudTrail, Kinesis Firehose. We're also leveraging Splunk and Honeycomb is a debugger that we're leveraging for production support. So what did we learn? We learned a lot, I can share that. One of the biggest things that we learned is implementing machine learning is a lot more complicated than traditional software development. A machine learning project is usually full of uncertainties. It involves gathering data, processing the data to train the algorithms, engineering the algorithms, and then training them to learn from the data. Therefore, it's really important to have patience and an experimentative approach when working with this type of project. As I mentioned, it's not your typical agile project. Also, the architecture that we just walked through was not our first, and it probably will not be our last. As we rolled out thin slices, we had to advance our architecture. In fact, one of our initial drops had a manual component. This helped us to test and learn and get feedback sooner rather than later. Agile is a powerful process for product development, but it does not mean we should avoid careful planning and preparation. When you're doing this type of work, you need to take a scientific approach. You need to have a plan, but you also need to see progress and understand how much you're willing to invest to get there. For me, this was one of the biggest learnings that I have found during this process. As I mentioned, these types of projects have a lot of uncertainty. And at times, I'll be very transparent. We miss some of our deliverables and our due dates, and we needed to replan. But that's okay. I think it's more important to show progress and understand that it is going to take longer than your average product. And again, have patience. So data plays a key role in any use case. 60% of the work of a data scientist lies in collecting the data. Since we are generating data for TORI, it's absolutely crucial to make sure that the data is representative of what the real world scenarios would be like. Otherwise, we would obtain a skewed understanding of the overall phenomenon. I'm sure most of you are familiar with the saying, garbage in is garbage out. That applies to this as well. So this is just one example of how Vanguard is leveraging technology to provide scalable advice. We have plenty other opportunities and examples that we could share. So if you're interested in joining us, please look at jobs@vanguard.com, because we are more than just a financial firm, we're a technology company as well. With that, I'm going to open it up to see if anybody has any questions.
So we got a question, Samy, this one's probably for you, on ways that the product got smarter with increased use.
So basically, we were able to identify what are the most important features to use for the machine learning models to be able to further eliminate the unnecessary features, or also like various transformations that were done to the features, the input features. Also, in terms of understanding the architecture or eliminating the number of classes, we went for revising the architecture that is built to configure to come up with better predictions.
We have two more questions here in the chat too that I'll read, and whoever feels more comfortable taking them. But thank you so much, Lindsey, Samy, and Christine. That was a great session here. First question, could you please address how you manage cybersecurity in this model, i.e. security of the data lake?
Sure. So I know I mentioned that we're using Secrets Manager, but we're also using AWS IAM, Identity and Access Management. So we're able to manage access to our services and resources securely.
Thanks, Christine. And the next question here, so around the model, how explainable is the model? And as an example, to kind of follow up and clarify the question, can you know why a client receives a specific recommendation from TORI?
Yeah, so this is actually one of the reasons why we turned to machine learning, and Samy might be able to talk to some of the technical details behind this, but through machine learning, we're able to identify some trends in which features drive different recommendations. And this has been a big benefit for us because now we can better understand which characteristics an investor might have to receive a certain strategy, and the technology is teaching us that.
And just to add to that, we're able to come up with the model explainability can be with various feature importance and other techniques that we can use to explain to the client how we've come up with a certain prediction based on their portfolio.
Thank you both. Those are all the questions that we have in the chat, but we do have a few more minutes in case anyone else has any others they'd like to ask our speakers. While those potentially last questions come in, I do want to just draw everyone to a chat that I threw into the chat room here. So we would encourage you to check out the Vanguard booth in the Expo Hall to learn more about opportunities about what we call #life at Vanguard. So understanding what are those opportunities to join our team and start your career potentially with us, or continue your career potentially with us here at Vanguard if you're interested in what you heard Samy, Christine, and Lindsey talk about today. Got plenty of hiring opportunities, and those are all linked through our career fair booth, as well as our social platforms and different hashtags that you can follow. And I'm going to scroll down here. It looks like we might have a few more questions that have come in. So next one here, how much can you balance between getting the product out quickly versus compliance, et cetera?
Yeah, I definitely think it is a balancing act, especially since we are, we have oversight, regulatory oversight and compliance. So definitely compliance and security are definitely at the forefront of our minds. And we have to balance how fast we can move. And sometimes that does slow us down, but I think we've done a really nice job of balancing between the two in order to deliver business value by withholding the compliance piece.
Yeah, and we've set some really high accuracy benchmarks for the model, so we won't show anything to clients that doesn't reach a very high accuracy threshold. And then we have some other checkpoints in place where we won't return to a client anything that could be worse off than conventional wisdom in any of those other cases. So we have definitely some strict measures in place to make sure that what we are showing the client, we feel really great about, and we know is helping to improve their outcomes based off of what they might be receiving previously.
Thank you both. Yeah, that's great to just underscore our focus on our clients at Vanguard. And Kelly made comment in the chat that she anticipates that it would be tricky for financial services. So Kelly, you've got that nail on the head right there.
You sure do.
And then the last question that we have, or one of the last questions that we have here, what was the hardest part of the project, or what part of the project might have surprised you the most?
I think the most complicated part for the ML piece was that we were to recommend a very vast number of strategies in the order of thousands. And so coming up with a machine learning model that is able to come up with the accurate predictions for the entire strategies requires a very good configuration of the architecture. So we needed to revise that architecture a couple of times by reiterating and doing multiple experimentations, and also like looking into what features are essential, what feature transforms are required, and also coming up with approaches in terms of using the tiered-based approach in machine learning, variations on the financial strategies having impacts on one another. So, and then and thinking of separating them and then seeing their impact. So there's a lot of correlation between the different financial strategies, which made this really complex.
Thanks, Samy. That's great. And just looking at the time, maybe time for one more question here. And I have some comments that I can add from the hiring perspective, but a question around how we might measure the disruption in the jobs due to AI/machine learning automation, and a question of, will an advisor lose his or her job?
I think the answer to that is absolutely not. I think this is a tool that will complement the advisor. And also I think it's going to help the advisor, with the time that they have to prepare, and just, having that interaction with the client. I think it's just going to make it more robust and a better conversation, more targeted, because there's a larger data set that is available now to those advisors.
And we know that these clients have all of these changing preferences, and they might not have a really deep understanding of the tax landscape that the advisor does have. So we expect this to really be a tool that's used as part of a conversation with an advisor and an investor, where they're really talking through the recommendation and able to change different inputs or different features that the client might have, or even override some of the outputs if it made more sense for them in their specific situation. And the machine's not going to be able to know that.
Great points. And Kelly made a comment here in the chat of how this is similar to how ATMs changed the job of a bank teller rather than purely replacing bank tellers. And I would completely agree with that, Kelly. And on the hiring front, we're continuing to hire advisors at Vanguard too. So if anyone on the line is a CFP professional, we're in tremendous need of additional financial advisors too. And if anything, AI and ML have freed them up to be doing more value-added work, right? And using that CFP designation to the fullest extent. Looks like we've maybe one final question that we could maybe quickly squeeze in before we wrap up. But was there ever any pressure from the leadership team about not progressing fast enough?
I think we understood that this was a different type of project. I think as long as we were showing progress, I think our senior leadership was comfortable with that. And I kind of spoke to that a little earlier. There was times where we did have to replan, and sometimes we didn't meet our deliverables. Because there is a lot of uncertainties, and with the data, especially with the data set as large as this one, there was things that we had to kind of work through. But I wouldn't say there was any pressure there. I think it was more, we had a ton of support and guidance. I think it was just more showing that we are making progress and just kind of outlining, like, here are some of the risks that we're willing to take.
Thanks, Christine. And that'll bring us right up to time. So I'll pass it back over to Julie.
Yeah, thank you so much. Thanks, everyone. Thanks, Vanguard team. Thank you to everybody asking questions, especially in the chat. We love to see that to keep up the engagement. So thank you for continuing to be a part of the Technically Developers Conference. Again, I'm Technically Managing Editor Julie Zeglin. I'm just here to move you on to the next session, which we will start at. You can hear from, Prefect CTO Chris White, who will be talking about spooky orchestration at a distance, how Prefect powers data workflows without accessing any data. So please do stretch your legs, walk around a little bit, come back and meet us at 2:40 back in the main stage. Thank you, everybody. Thanks, Vanguard, again.